Right, so I'm going to talk today about the rise and fall of 19th century atmospheric railways. And we're just going to be looking at, we're going to focus on these four main railways that actually got into operational service. So there were lots of other systems proposed and experimented with. And there were other sort of pneumatic type systems where the whole train was stuck in a tube, but we're going to focus on these atmospheric ones. And to put this in a kind of Clifton suspension bridge context, this sort of rather tarnished golden age of atmospheric railways roughly coincided with the years when the build of the Clifton Bridge was stalled because there was no money. So we're talking early 1840s through just getting into the 1860s for the sort of operational phase. But we're going to start with a little atmospheric railway prehistory. So quite a few people were playing with ideas about atmospheric railways way back. Probably the best known of the early ones at the very beginning was this chap, George Medhurst, and he proposed all sorts of atmospheric ideas, including this thing here, which was a atmospheric carriage. And he promised that this thing would get you up to 60 miles an hour without horses. I can't imagine a carriage could even do 60 miles an hour with horses. But anyway, so that's Medhurst. And he was followed later by this chap, Henry Pincus, who was an American who'd come over to Britain. And he had an idea of replacing many of the major carriage routes on roads with this atmospheric railway system. And he built some test tracks, but never actually got anything into proper operational service. But we're going to use his system to just have a little look at how atmospheric railway systems work. So they have a tube running the whole length of the line. They have pumping stations run by steam engines every so often. And these things pump air out of the tube. So they create low pressure in the tube ahead of the engine. We have a train, obviously, with some passengers. And then we have a gubbins, which usually called a piston carriage, which is connected to a piston in the tube, which is pulled along by the pressure difference in the tube, and in turn pulls along the train for us. I love the Pincus design of this piston carriage. It's incredibly minimalist, complete lack of regard for the protection or comfort of the poor driver there. He's just sort of stuck on the top, but it's really pared down to the basics. And let's have a look at how this thing actually works inside. So this is like one of Pincus's drawings of a cross section through this. We've got the tube down at the bottom there running all the way across. And inside we've got this piston with the low pressure on the left from the pumping station, which is some way off to our left. And we've got normal atmospheric pressure air on the other side behind the piston. And that creates a pressure difference, which is going to push our train along. We need some sort of gubbins, which is going to enable the piston to be connected to the carriage above. And here's the really tricky bit on atmospheric railway. This requires us to have a slot cut the full length of the top of the tube in order to allow this gubbins to go through. But the trouble with that is that, of course, it'll let the air out. So we need a way of sealing the tube. And from the Pincus system, he used a rope soaked in tallow and a set of wheels here, which guided the rope. It kept it pushed down onto the tube ahead of the engine where we need to create a seal, but lifted it up where the carriage was going past so that this connection could be made. And then there's another wheel to push it back down. So why would you go for all this terrible complexity and mess? Well, the one really good thing about atmospheric railways, if they work, is that they're very good at going up gradients. And there's two reasons. One is that they have inherently better traction. They don't need a good traction between the railway and the rail, if you like, or the track and the engine. And a conventional locomotive, that traction actually gets worse as you start going uphill. And you don't have to carry the weight of the engine or any of the fuel to run it. So that's pretty good. It's also quite quiet for passengers, and you don't get smoke and smuts. So conventional railways of the day, were pretty dirty things. And if you were in an open carriage, you got covered in smuts and so on. Trouble is, there's lots of things wrong with atmospheric railways, or difficult. Junctions between lines are just a complete nightmare to implement, if not impossible. Sealing the tube, as we've already talked about, was really difficult. And to come up, nobody really established a reliable, consistently reliable way of sealing up the tubes. They're incompatible with conventional railways. If you want to connect with any other sort of railway, you're in trouble. And particularly when the railways get long, you need some form of communication between the train and the pumping stations so that you know when to run them. And if you don't, you just have to run them continuously, which uses lots of fuel. So going back to our little history, following on from Pincus, the two really big players were these two guys here, Samuel Clegg and Joseph Samuda. Clegg was really much better known for his work in the gas industry, gas production, gas lighting, gas meters, all that sort of stuff. Joseph Samuda, very successful engineer, later a politician, in fact, and works a lot with his brother Jacob. They were into sort of marine engineering as well. And they produced a patent in 1838, which really forms the basis of the design of all of the four main railways that we're going to be looking at today. And you can see the main elements of the Pincus system present and correct here, although in slightly different forms. Other interesting things in here to note, we've got a system here for controlling the power by opening a valve through the piston, which allows us to reduce the pressure difference, so we can reduce the power we've got. And also on their system, there's a little burner here, little fire burning, which is used to melt the tallow on the leather flap that forms the seal on the tube. And this, so this is a way of trying to get a better seal, a more reliable seal. I should have mentioned that Clegg and Samuda used a leather flap rather than a rope, as in on the Pincus system. So they built a test track, and people were quite impressed. They did public demonstrations and so on. And their first customer was this bunch here, the Dublin and Kingstown Railway in Ireland. And they had a railway, conventional railway, running from Dublin out to Kingstown, which is, the Kingstown was to Dublin what sort of Avonmouth is to Bristol, really, a sort of suburb come port. And they wanted to extend the line up to this place called Dalkey. And Dalkey was on the site of a mineral quarry. And there was already an existing tramway running down from the quarry down to Kingstown. So they had a route already, but it was very steep, particularly for a locomotive. And so they thought this atmospheric stuff would be just what they needed. And this is the line that they built. This picture actually comes from a French report on the railway, which we'll come on to a bit later on. So actually, this is a very short line. It's only 2 miles long. It only needed one pumping station up at the top. And it was very steep, actually perfectly matched to what atmospheric railways could do, what they were good at, without you getting too involved with some of the things that they were so bad at. Here's the little picture of the opening ceremony. So when this went into operation, it was the world's first commercial atmospheric railway. They were running 4 trains an hour, 2 going up, 2 coming down. They got up to over 30 miles an hour going uphill, which was pretty impressive. The train, actually, the atmospheric tube finished short of the Dalkey station at the top. So the train would just coast into the station under momentum at the end. If you didn't quite make it into the station, you just asked the third-class passengers to get out and push. Probably not something we could get away with today. to come back down the slope, they simply pushed the train out of the station and it ran all the way down under gravity to get back down to Kingstown. It was quite a successful railway. It ran for over 10 years and it eventually went out of service only really when they wanted to build additional line and extend the line and connect it up with conventional railways. As atmospheric railways go, tolerably successful. The next one, not such a happy tale. This is the London and Croydon Railway. They already had an existing line, conventional railway from London to Croydon, and they wanted to increase capacity. So they decided they would build a parallel atmospheric line. They had a bit of problem with NIMBYism. Nobody liked the idea of having these pumping stations built in their backyard, and so they went to a lot of trouble to try and make them acceptable. So they built these rather, I don't know whether it's beautiful, but it's certainly amazing, these sort of heavily Gothic pumping stations come railway stations, and they looked, I mean, this one to me looks more like a church almost. So this one's at Croydon. You can just see a little bit of atmospheric tube peeking into the picture on the bottom left. Here's another one, not such a nice picture, but it shows, you can just see it there. There's an atmospheric train there in the foreground. And of course, no locomotive, of course, because it's atmospheric. Now, this line also featured the world's first railway flyover. We've already said that junctions are a complete nightmare for atmospheric engines, so atmospheric railways. So rather than having to somehow work a junction, they built a flyover instead, where they had to cross a conventional railway. You probably couldn't make a flyover like this work for a conventional railway of its day, but fortunately, because the atmospheric system was good at going up hills, flyovers work. Here's a London and Croydon piston carriage with this rather splendid fellow driving it. He's hanging on to that thing in his hand there. That's the brake. In front of him, he's got the lever which opens the valve so he can reduce power. And although you can't see it very clearly in this picture, in that little cubby hole there on the left, which is the only shelter he's got from the weather, there's a barometer which is hooked up to measure the pressure difference between the air on each side of the piston. In other words, it gives the driver a measure of how much power he's got available to him. Well, the London Croydon Atmospheric Railway didn't last very long. Operational life was only of the order of 18 months. The railway was taken over by the London, Brighton, South Coast Railway, and they really weren't interested in continuing this atmospheric experiment. It hadn't been very reliable, and they were heavily invested in conventional railways, and joining it all up was a nightmare. So they pulled the plug just after, as I say, 18 months or so. And next one is Paris Saint-Germain. So that was another existing railway that ran out from Paris to Le Pec on the banks of the Seine. And they got a government grant to extend their railway up to this place here, this Chateau Saint-Germain, which was quite a popular tourist attraction. And they reckoned that there was money to be made by extending the railway up and taking tourists out of Paris up to visit the chateau. Bit like Dalkey, there was quite a gradient to deal with. And this charming little picture by Turner shows you, this is a view from the terrace of the chateau, and you can see just how steep it was. Got the River Seine down at the bottom, and the railway was going to have to come along that valley, cross the river, and up to the top here. Here's what here's the route of the end of the route of the Paris Saint-Germain Railway, and this little bit in red at the end is the only bit that was atmospheric. So the chateau is right there on the very far left of this picture, and we've got, again, a bit like Dalkey, just a couple of miles of track going up a steep hill. So very simple arrangement. The station at the top is really quite remarkable. This is a picture was taken after the track was turned back to a conventional railway, but they you couldn't have got the station any closer to the chateau. In fact, they destroyed a fair bit of the formal gardens at the front of the chateau in order to build the station. I don't think we'd get away with that today. Now, in order to build this railway and get the materials up that steep incline, they decided they would have built for them a special locomotive, conventional locomotive, optimized for going up steep hills. And this was it. It was called the L'Hercule. Nothing to do with Poirot, I don't think. 1846. And this was an incredible little locomotive. It was so good at its job, very embarrassingly, they discovered that it was perfectly capable of pulling a fully laden atmospheric train all the way up to the top. So this is a rather ominous moment in the history of atmospheric railways. Here's a conventional locomotive that could do the one thing that atmospheric railways are supposed to be really good at, which was going up steep hills. So really, this locomotive made atmospheric railways obsolete. The Paris Saint-Germain atmospheric railway was obsolete before it was even finished. But they'd had a government grant to build an atmospheric railway, so they went ahead and completed it. Here's a piston carriage from theirs, and although there are some slight differences from the other ones we've seen, essentially this is the Clegg-Samuda system being used once again. They ran for 11 years with what was described as pretty good, if not spectacular, performance. So they still had reliability problems and so on, but it kind of worked. But in September 1858, they had a rather nasty accident. An atmospheric train had its brakes fail up near the top, and it ran full tilt all the way down the line, and it crashed into a conventional locomotive waiting at the bottom to transfer passengers. The driver and a couple of passengers in the atmospheric train were killed. And as you can see in this picture, I mean, the steam locomotives come out of this tolerably well. The atmospheric railway has been reduced to matchwood at the front there. They did rebuild the carriages and they got it going again. But after 13 years of operation, they eventually packed up in 1860. And L'Hercule took over the duties of hauling the trains up to the top. And the whole line was eventually electrified in 1920. So we come to our last one, the South Devon Railway. Actually, I'm not going to say so much about this one because it's the one that people know more about. Obviously, very much associated with Brunel. And Brunel deliberately selected the atmospheric railway because he liked the idea of introducing some fairly steep gradients. He thought it would help him do a better route for the railway. But as history shows, a fairly misguided decision in the end. Here's not much of his railway remains. Here's a bit of atmospheric tube from the South Devon at the Didcot railway station. He had pumping stations every couple of miles along the track. They achieved speeds of around about 20 miles an hour for the trains. So here we have Dawlish with the engine and station, the station and the engine house. And you can see the atmospheric track there in the foreground. A chap called William Dawson produced a lovely series of diagrams and watercolors during the build phase of the South Devon. And so it's quite remarkable because I've got some pictures here of people actually building the railway. I suspect it's been somewhat romanticized, this lovely pastoral setting, but you can see some guys putting some tubes down there. This is what Exeter St Thomas used to look like in atmospheric days. The railway was pretty reliable at the very beginning, actually. They got some actually remarkably good performance before the thing was fully open. And this is the kind of performance that I think quite a few modern day railway lines would love to achieve. However, it didn't really last very long. Once they got into full operational service and once a bit of wear and tear began to kick in, all sorts of problems began to emerge. The valves were freezing up in the winter and then they were drying out in the summer. So the leather flap that was so essential for the seal didn't really work reliably. And you've got a sort of deadly embrace of the more delays and cancellations, the more problems you had communicating with your pumping stations, because you didn't quite know if the train was late or running. So you end up using far more fuel. So the economics were all going wrong. But they did start to get it debugged. They were actually working with new rubber valves, and things were getting a bit better. But really, patience of the directors are worn thin, and they could see that really this wasn't the way to go. And the whole thing, the plugs were pulled in 1848, and it was all converted back to conventional line. Couple of myths about the South Devon Railway that we often hear. There is very little evidence that rats ate the leather flaps. Really, the problems with the flaps were to do with weather and not rodents. The other thing we often hear about Brunel and the atmospheric railway is that Brunel somehow invented atmospheric railways, whereas in fact he was an early to mid adopter, perhaps. He just selected what was then an emerging technology, and he certainly did select the wrong technology. So if we look at the 4 railways again that we've covered, it is notable that the 2 that were tolerably successful, the Kingstown to Dalkey and the Paris Saint-Germain, were both very, very short, just a couple of miles each. They only had 1 pumping station. They were also on a very steep hill, so they were playing to the advantages of the atmospheric railway, whereas the other 2, which were trying to do much longer distances with multiple stations and interacting with other railways, were complete failures. Okay, well, I think I've already probably overrun like mad, so I'm going to stop there.